All right, good day everyone. So let us talk about testing the difference between two means, that is dependent samples. So testing the difference between two means, dependent samples. So the testing between the difference between two means for dependent samples, also known as a paired samples or matched pairs, involves analyzing data where the observation in one group are linked or paired with observation in other groups. This commonly occurs before and after studies, twin studies, or any situation where the same subjects are measured under two conditions. So that is a pair samples or match pairs, linked or paired before and after studies, twin studies, or any situation where the same subjects are measured under the two conditions. So we have here when to use a dependent samples t-test. So use this when the same subjects are measured twice. So same subjects are measured twice. We have here from before and after. So subjects are naturally paired, twins and matched individuals. So naturally paired. And you're comparing two related measurements. So that is a testing difference between two samples when to use. An assumption for t-test for two means when the samples are dependent. The first one is that the samples are random and the sample data are dependent. And if the sample size or sample sizes are less than 30, the population or populations must be normally or approximately normally distributed. So we have here testing the difference between two means dependent samples. So this is the formula. T is equal to the mean of the difference of the sample minus mu d, that is the population mean of the difference usually under the null hypothesis, that is 0. And SD is the sample standard deviation of the difference and the number of pairs observation, that is n. So this is the formula in finding the the difference between two means dependent samples. So with df is equal to n minus 1, and where this bar d mean of the difference in the sample is equal to the summation of d over n, and sd is equal to the square root of n times the summation of d squared minus the quantity of the summation of d squared over n times n minus 1. So that's how to find the formula for t-dependent samples. So testing difference between two means dependent samples. So there are procedure table. Step 1, state the hypothesis and identify the claim. Step 2, find the critical values or values. And step 3, compute the test value. So you have to make a table, x and x sub 2 and so on, and find the difference and place the results in column A. So you have to take the difference and you get the sum and find the difference, that is differences. Then bar d is equal to summation of d over n, and square the differences and place that in column B and complete the table. Find the standard deviation based on the formula, then find the test value. So the test value is equal to bar d minus mu d over square sd over square root of n, with the df degrees of freedom n is equal minus 1. So after the 1, you have to make a decision and summarize the results. Okay. Let's proceed with the first problem. So the first problem states that a dietitian wishes to see if the person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 randomly selected and they took mineral supplement for 6 weeks. The results are shown in the table. Okay, so cholesterol level is measured in milligrams per deciliter. Can it be concluded that the cholesterol level has been changed at 0.10. Assume that the variable is approximately normally distributed. So we have here the subject 1 to 6, and before that is 210, 235, 208, 190, 172, and 244. And after we have 190, 170, 210, 188, and 170, and 228. So these are the data about this problem. So before and after, so in this, it is understood that this is dependent sample. So we are assuming that the variable is approximately normally distributed, because if not, we'll be using non-parametric tests. But since it is normal, assumption of normality, so therefore we'll make us t-test for dependent samples. Okay, so we have here step number 1. We have to state the hypothesis and identify the claim. So, first is this one. What is our hypothesis? Our HO is that mu D is equal to 0. If the diet is effective, the before cholesterol level should be different from after level. So therefore, our H1 here is that mu D is not equal to 0. So that is, so the difference, there's no difference, and the difference is equal to 0, and the difference is not equal to 0. So therefore, it's stated that can it be concluded that the cholesterol level has been changed? So this is our claim. Okay, so mu D. So mu D, so we are going to go back here. What is a mu D is stated here that usually under the null hypothesis that is equal to 0. So our mu D, so population means difference. So population mean difference, so we have to compute from sample to population. So no difference, and there is a difference. It's not equal to 0. Next, we have to, step number 2, we have to find the critical value. So our DF here is equal to, we have 6, so 6 minus 1, that is 5. Then at alpha, 0.10. So we're going to look here, since this is a two-tailed test, two-tailed 0.10, and the alpha is n minus 1 is 5, that is 2.015. So our critical value, since this is two-tailed test, positive and negative, 2.015. Step number 3. So in step number 3, we have to make a table. So we have here before. This one is before and after. Before is our x sub 1, and after is our x sub 2. So we're going to place this one, the data, 210, 235, 208, 190, 172, 244. Then after which, the after is 190, 170, the pair of this one is 210, 188, 173, and 228. Next is we have to find the difference, RD. So from x sub 1 minus x sub 2, because this is the process, so x1 and x sub 2. After the 1, you have to take the difference. So 210 minus 190, that is equal to 20. That is 205, 170, that is 65. This is negative 2. This is 2. This is negative 1 and 16. Then after that 1, we are going to take the sum. Summation of D is equal to 100. Okay, next step is we have to square the difference. So we have to square the difference. Okay. So we have here 20, then square this one, we have 400. Then 65 square, we have 4,225. Then square this 2 is 4. This one is 4, 1, and 16 times 16, that is 256. Then after that one, we get the sum. Summation of d squared is equal to 4,890. So what we are going to do in the formula is we need to find the dx sub 1 and bar t. So in the formula, this is the formula. We're going to look for SD and the bar D. Okay, so first we need to find for the bar D. The bar D is equal to summation of D over Rn. What is our summation of D? 100. So 100 divided by 6, that is equal to 16.7. Okay, 16.7. So this is our bar D. Then after which, we are going to compute for our SD. Our SD is square root of, we have here n summation of d squared minus summation of d squared over n times n minus 1. So first is we have to find for the SD, we have square root of, we have 6 times, this is 4890 minus summation of d is 100 squared, because this is our summation of d over, we have 6 times 6 minus 1. So our SD here is, the square root of this one is 6 times 4, 980 is 29,340 minus 10,000 over 6 times 5 minus here, they have 30. So taking the solving this one using your calculator, 29,340 minus 10,000 over 30, then take the square root, we have 25.4. Our SD is equal to 25.4. And after that one, we have to take the test value. So bar D minus mu D over SD over the square root of n. So what is our bar D? The bar D here is 16.7 minus 0 over, what is our SD is 25.4 over the square root of 6. So if we're going to solve this one, 16.7 minus 0 over 25.4 over square root of 6, that is equal to 1.610. So this is our test value. So we have to compare this one in the critical value. Okay, step number 4. So we are going to use a graph here. So what is our critical values? Our critical values are 2.105. This is negative 2.015. And the positive side is 2.015. So we have to shade this one. And our test value is, that is 1.610. So what is our decision here? The decision is, do not reject HO, since the test value 1.610 is in the non-critical region. So this is our step number 4. In step number 5, so we're going to look here if our claim is our H1, so therefore, since the null hypothesis is not rejected, so you could say that there is enough evidence to support the claim that the mineral changes a person's cholesterol level. Okay, so that's it for problem number 1. Okay, before and after. So let's proceed now with problem number 2. In problem number 2, a random sample of 9 local banks shows their deposits in millions of dollars 3 years ago and their deposit in billions of dollars today. At alpha 0.05, can it be concluded that the average in deposits for the bank is greater today than it was 3 years ago? So greater today than it was 3 years ago. It means that we are interested to see if there has been an increase in deposit. The deposit 3 years ago must be less than the deposits today, since hence the deposits must be significantly less 3 years ago than they are today. So therefore, we have to state the first statement is we have to state the null hypothesis or state of the hypothesis. So HO mu D is equal to 0 and our H1 is mu D is lesser than 0, which is our claim. Why is it lesser than 0? Which in fact, you're stating greater today than it was 3 years ago. Meaning to say, we are interested on the increase. The deposit of 3 years ago must be less than deposit today. So that is kabaliktaran. But 3 years ago, so I mean to say, we are going to get that UD is lesser than 0. That is our claim. Next, step number 2 is we need to find the critical value. So our degrees of freedom here, so we have here 10, 9. So 9. So 9 minus 1 is equal to 8 at alpha 0.05. So this is a one tail. So one tail. And the alpha is 0.05 and 9 that is equal to 8. 8. This is negative 1 point. So therefore our critical value is, since that's lesser, so this is negative 1.860. Since the critical value is left tail, so therefore we are using negative 1.860. That's left tail test. So step number 3. So we're going to proceed with the table here. Step number 3. So first is 3 years ago. These are x sub 1. And today we have x sub 2. Then same process here. If we problem number 1, d is equal to x sub 1 minus x sub 2. Then next is letter B. We have d squared is equal to x sub 1 minus x sub 2. Then we have to get the square. Next, we are going to copy all this one. 11.42, 8.41, 3.98 the data, 7.37, 2.28, 1.10, 1.00, since two decimal places, 0.90, and 1.35. So for today, we have here 16.69, 9.44, 6.53, we have 5.58, 2.2, 2.92 rather. So we have here 1.88, 1.78, 1.50, and 1.22. Then after that one, we are going to get the difference. So 11.42 and 16.69 is negative 5.27. So 8.41 minus 9.42 that is negative 1.03. 3.982 minus 6.53 that is negative 2.55. So 7.37 minus 5.58 that is positive 1.79. Then 2.28 minus 2.92 that is negative 0.64. 1.10, 1.8 is negative 0.78. 1.1 minus 1.78 is negative 0.78. Then 0.9 minus 1.0 that is negative 0.60. And 1.35 minus 1.22 that is positive 0.13. Then after which we get the sum, we have summation of D is equal to, get the sum here, calculator negative 9.73. After we are going to find the bar D. Our bar D is summation of D over Rn. So what is our summation? This negative 9.73 over Rn is 9. So approximately the result of this one is negative 1.081. Next step is we need to square. Okay, we need to square this one. You square this negative 5.27. We have to square. The result of this one is 27.7729. Square of 1 point is 1.0609. 2.55 is 6.5025. Our positive 1.79 that is 3.2041. Negative 64 that is 0.4096. And 78 this is 0.6084. 0.6084. And we have here 0.3600. And 0.13 squared is 0.0169. And after this, we have to take the summation of d squared is equal to 40,000, 40.5437. So this is our d squared, summation of d squared. After which, we are going to compute for this one. Okay, to compute for SD, we have the square root of n times summation of d squared times minus summation of d squared over n times n minus 1. So our SD is equal to the square root of, we have 9 times 40 point, this summation of 40.5437, 5437 minus our summation of d is 9.73, negative 9.73 then square over 9 times 9 minus 1. So our SD is equal to, so we are going to simplify this one, this is square root of 270.2204 over 72. So therefore our SD here is equal to 1.937. So we have now the SD. So by the use of t-test, So bar D minus mu D over SD over square root of n. So what is our bar D? Negative 1.081 minus mu D is equal to 0 over, because in our hypothesis, mu D is equal to 0. And next is SD is 1.937 over the square root of, what is our n here is 9. Then is equal to negative 1.674. So next we are going to make a decision. So step number 4, we have to make our decision. Since this is a left-field test, okay, so expected that our critical values is negative 1.860. 1.860, but the resulting is negative 1.674. It means that we have do not reject HO. Since the test value, since the test value is greater than the critical value, negative 1.860. Okay, then after the one, step number 5. So since our mu d, our h1 is our claim, so by using the process that we're going to state that there is enough evidence to show that the deposits have increased over the last 3 years. So which is number to the solution number 2. Okay, so let's proceed now with try this improving study habits. A's and 8 for improving students to study habits. 9 students were randomly selected to attend the seminar on the importance of education in life. The table shows the number of hours each student studied per week before and after the seminar. At alpha 0.10, did attending the seminar increase the number of hours the students studied per week? So before and after. So thank you so much for listening for this T-test of dependence.